My name's Colleen Geary, and this is my Lab 2 board demonstration. I'm going to start out with opcode 0000, and that is A plus B without Cn. As you can see, B is already set at 2. So if I were to make A 1, then 1 plus 2 equals 3. When I make A 2, 2 plus 2 equals 4. If I make A 6, I get 6 plus 2 equals 8, and then I have my overflow bit turns on. And then if I were to make a 14, whoops, that's not the right one, sorry. If I make it 14, then my Cout bit comes on, because now 14 plus 2 equals 16, and that's why you see all zeros. You can also see that my Cin bit does not affect my outcome at all. Change all my A's back. So now I'm going to change to opcode 0001, and this is A plus B with Cn. I'm going to do the same sequence I did earlier, but with Cn and without Cn. So currently I am without Cn, so it'll be the same as it was before. So 1 plus 2 equals 3, 2 plus 2 equals 4, 6 plus 2 equals 8, and then you get the overflow bit, and then 2 plus 14 equals 16, and then you get your Cout. So now I'm going to switch these back. Now I turn my Cn bit on, and automatically that makes B equal to 3. So if I were to add 1 to 3, you get 4. If I add 2 to 3, you get 5, sorry. If I add 6 to 3, I get 9, and then we have our overflow bit. And then if I add 14 to 3, I get 17, so I get my Cout, plus it starts over, so I have my other 1 bit for 17. So now I'm going to take those all away. Turn that off. And now I'm going to change my opcode to 0010, and that is for A minus B, no Cn. So in this one, B is turned into the 2's complement form, which for 2 ends up being 1110. Now if I take 1 minus 2, I get -1. If I take 2 minus 2, I get 0 and my Cout bit. If I get, and then let me see, 6, yep, 6 minus 2, I get 4 and my Cout bit again. So now I'm going to go to my next opcode, which is for shift logical right, and that is 0011. So you no longer see the B because it does not matter in this instance. Because, oh, I mean, B does matter. That's what I'm going to shift by, but you don't see it coming up on the output anymore. Okay, so if I have, and as you can see, Cn does not affect that outcome at all. So if I make a 0110, and it is shifted to the right by 2, which is B, then I get 0001. And then if A is 1110 and it is shifted to the right by 2, I get 0011. Now I'm going to turn those off and change this to shift arithmetic right. I don't know if I said that right, probably not. As you can see, again, there's no output because A has not been entered yet. And so if I enter A, and the Cn bit doesn't affect this at all. So in this instance, to do the shift arithmetic right, it's going to do the 2's complement of A. And so In this first case, I'm going to make A 0, 1, 1, 0. And so the 2's complement of that is 1, 0, 1, 0. And when it is shifted to the right by 2, it ends up being 1, 1, 1, 0, because the 1's follow as you shift to the right. And then if I were to make, whoops, sorry, that was the wrong, nope, that was the right button. And if I were to make a 1, 1, 1, 0, the 2's complement of that is 0, 0, 1, 0, and then when you shift that to the right by 2, you end up with 0, 0, 0, 0. I'm now going to change to my opcode 0101, and that is for the shift left, shift logical left. So I'm going to, and you can see that CN does not affect this output at all. So first I'm going to make a 1, I'm going to make a 0, 1, 1, 1, and then when that is shifted to the left by 2, it becomes 1, 1, 0, 0. And if I were to make a 0, 0, 0, 1, it's going to get shifted to the left by 2 and gives you 0, 1, 0, 0. And then the last, now I've got to do shift arithmetic left, and that is going to actually be the same outcome as the one I just did. So you can see that the CN does not affect it. If I do A as 0, 1, 1, 1, it shifts it to the right, and it gives you 1, 1, 0, 0. And if I do 0, 0, 0, 1, it shifts it to the right and gives you 0, 1, 0, 0. Now I'm going to do my last one. This is not A, so that for the opcode for that is 0, 1, 1, 1. And as you can see, when I don't have anything for A, the not of that is 1, 1, 1, 1. If I were to turn A into 1, 1, 0, 1, I'm going to get back 0 or 1, 1, 1, 0. Sorry, I said that wrong. If I put in 0, 0, 0, 1, I'm going to get back 1, 1, 1, 0. And then if I put in 1, 1, 0, 1, then I'm going to get back 0, 0, 1, 0. So that concludes my test. I hope that I've shown you everything you needed to see. Also, CN does not work on the not A. And thank you for your time.